The hardware-defined product. A hardware-defined product integrates the capabilities of physical hardware directly into the product's core functionalities, enhancing performance, reliability, and user experience. By embedding specialized hardware components, these products can perform tasks more efficiently and handle complex operations that software alone cannot manage. This approach often leads to greater customization and optimization, meeting specific user needs and industry requirements. As technology advances, the line between hardware and software continues to blur, enabling innovative solutions and more versatile products.
Hardware overview. The hardware-defined product is a crucial component of an IoT system designed to collect data from various sources at the edge, occasionally process it, and then transmit it over the network to the application layer. In an IoT setup, the edge can be located within the product itself or distributed across a broader system or environment. The hardware-defined product is comprised of two primary elements: connected sensors and actuators, and an embedded system. This product is strictly limited to these components and does not include other physical aspects of the device. Sensors gather data from the physical environment, while actuators perform physical modifications to the product. The embedded system collects this data, packages it, and sends it through the network to the application. Additionally, it may conduct local processing related to the application, analytics, or security functions. The hardware-defined product captures internal sensor data and transmits it via the operational technology (OT) network to the software-defined product for further processing. Sensors. Sensors have been around for over half a century, but accessing them via the internet is a relatively recent development. No matter the data needs, there is a sensor available to capture the necessary information. It's crucial to understand that the value drives the selection of a sensor. Value determines the required information, which in turn dictates the data to be captured, and ultimately, the sensor to be used. The main challenge lies in finding the right sensor. Selecting a sensor is just the first step. It's essential to invest in R&D to test and verify its specifications before implementation. A sensor's transducer converts physical phenomena into a DC current, which is then digitized by an A to D converter. Actuators work in reverse, converting digital signals from applications into physical actions via AD to a converter. For example, in an IoT dryer, an actuator might adjust fan speed or heating coil temperature. To connect a sensor to the internet, an embedded system is required to package the digital data and send it through the OT network to the application. The real value of an IoT product lies in transforming sensor data into useful information. Sensors are one of the primary data sources in IoT systems. Embedded systems. Embedded systems are specialized computing devices integral to IoT products, primarily tasked with connecting sensors to the internet. An IoT product can be a standalone device, a comprehensive system, or a specific environment. Often referred to as embedded chipsets, these systems function at the network's edge, utilizing a microprocessor unit, MPU, instead of a traditional CPU, and running a real-time operating system, RTOS, rather than a standard OS. Embedded systems may also incorporate radios and sensors. Their main role is to facilitate communication between sensors and the operational technology, OT, network, packaging sensor data into a protocol and transmitting it across the network. Additionally, these systems can store and execute local applications, perform analytics, and ensure security. While their primary function is data transmission, there is a growing trend towards mist computing, which involves executing applications, analytics, and security tasks directly at the network's edge. Connected sensors. To connect a sensor to the internet, both computing and networking capabilities are necessary, which are provided by the embedded system. This setup involves a sensor and an embedded system, similar to the architecture used for actuators. A connected sensor system includes a microprocessor unit, MPU, input-output interfaces, power supply, and optionally, radios. The sensor itself comprises a transducer and an analog front end, or an actuator and a digital front end. There are two primary configurations for connected sensors: standalone and sensor arrays. A standalone connected sensor features a single embedded system with one sensor, often integrated into existing products. In contrast, Connected sensor arrays involve one embedded system managing multiple sensors, typically used in new products. For instance, an IoT dryer would utilize a connected sensor array. Standalone sensors are commonly deployed in commercial, industrial, and infrastructure IoT to add an overlay network to costly existing products. Sensor arrays, on the other hand, are prevalent in consumer IoT and new business IoT products.
Thanks for joining our video. Would you be interested to know more? Please contact us to www.icertglobal.com or email to info@icertglobal.org.